Okay, continue on functions and graph 5.1. These are the learning outcome for these subtopics. Domain and range. Domain of a function. This is the notation for domain. Domain of a function is the set of all real value of x such that fx is defined as real number, usually refer to the interval of x. Range of a function f is the set of all possible real value of fx for each value of x in the domain, or usually refer to interval of fx. Domain is the value of x and range is the values of fx. There are two ways to find the domain and range. First, using graphical method. For linear function below, domain of f is denoted f t of f equal to, we look at the x-axis, so where the graph start and end. So in this case, the linear function, this line will continue to the left until negative infinity. So domain is negative infinity to infinity, as the graph won't stop at any point. So domain is from negative infinity to infinity. And then range. For range of f, look at the y-axis. So this graph going from below means from negative infinity up to infinity. Then second graph, so linear graph, negative x. And then this graph, domain, look at the x-axis. The graph start at negative infinity and going through the x-axis to infinity, as the graph will always going down to infinity. And then range, look at the y-axis. The graph will continue from below, means negative infinity, to going up and won't stop at any point, means up to infinity. And then next example, this graph has starting point negative 2, 4, means domain for f is negative 2. There are no graph for x less than negative 2. Okay, so and not included means negative 2 open interval up to, and this graph is going straight. There are no stopping point here, so up to infinity. And then range from y-axis. So y-axis, the graph start at negative 4. There are no graph below negative 4. So negative 4 is the range of this graph up to infinity. Next example is power function. For the domain for this example, again we look at the x-axis. The graph start at negative infinity and end at infinity. And range for f, graph start from above, means infinity and going down up to 0. There are no graph below 0 point. So the lowest point for this graph is 0. And then again going up to infinity, so highest point will be infinity, and 0 is included as the graph will cross x equal to 0. Second example, again quadratic, negative x squared. Domain of f equal to, look at the x-axis, start from negative infinity here, going to 0, and then going through to infinity. So domain is negative infinity to infinity. There are no stopping for x. And then range of this function start from below negative infinity and then going up to 0 and then again going down. So this lowest point for this graph is negative infinity to highest point is 0. There are no graph above 0 point. So this will be the range of fx. Next example, for domain of f equal to, again we look at the most left point of x is negative infinity, and then going through 0 and then going up again, no stopping point, so up to infinity. Then range of f is from above infinity going down to 2. Here lowest point is 2, so graph won't cross point 2, means lowest point for this graph is 2 to infinity. And then cubic function. For cubic function, domain, look at the x-axis. Again, this graph has no stopping point, so negative infinity to infinity. And then range, graph start from below, negative infinity to 0 and then above infinity. Second example, domain, no stopping point, so negative infinity to infinity. And then range start from above going down, so again no stopping point, negative infinity to infinity. Then next example, cubic graph, start from domain negative infinity, and then this graph has stopping point 1, 5, so value of x is 1, means domain negative infinity up to 1 included the 1, close bracket. And then range of f equal to, look at the y-axis, the graph start from below negative infinity and then stop at 5, again included. Next example is a root function. Okay, root function, domain is starting point 0 to infinity. There are no graph below 0, so starting from 0 to infinity. And then range start from again 0 and above, so there are no graph below 0, means range is 0 to infinity. Next example, graph start from 0 and to the left, so domain is from negative infinity, the most left value is negative infinity up to 0 included, and range is start from 0 and above, so range is 0 to infinity. And then next example, domain, the most left value for this graph is 0 here, it means 0 and to the right, so positive infinity. Range is from lowest point negative 2 and above, so infinity. Next example, domain from negative infinity to 0. There are no graph above 0. And then range start from below negative infinity and up to 1. There are no graph for y greater than 1, so range start from negative infinity up to negative 1 included. Next example, 5, 1. Again, domain of f start from starting point 5 and infinity going to the right, and range lowest value of graph is 1, so range start from 1 and going up, so up to infinity. For absolute values graph, domain is from negative infinity 0 to infinity. So negative infinity to infinity, and range is from lowest value of graph 0 to infinity. Next example, domain. The most left value is negative infinity up to infinity, and then range start from negative infinity below graph up to 0. There are no graph above 0. So for this graph has vertex negative 2, 3. So domain from left negative infinity to infinity, and range is from lowest value of vertex is 3 to infinity. Next function, vertex is at 3, so domain, there are no stopping the graph, negative infinity to infinity, and range is from lowest value of y 0 to infinity.